Hi, I'm Percy Tzelnic. I want to start this by saying, with my new colleague, Ed Turkel, happy birthday to a new company that has been born today. I was assured that at the end of my presentation, a big birthday cake will come and be circulated around. Correct, right? With one candle on it.
Yeah, only one candle.
Okay, so EMC's journey in HPC, which is what I'm going to talk about for a few minutes today, has been interesting, to use a qualifier that is not widely used here. It really, people in this audience may know of EMC, as the rest of the market does, is a quintessential enterprise storage vendor with probably the largest part of the worldwide enterprise storage, from EMC. There have been, we have been with EMC for a long time, almost 20 years. So all along there have been attempts to sell EMC storage in the HPC market. And some were really very successful. But there has not been an HPC program until 2010. What happened in 2010 is that Joe Tucci and Pat Gelsinger, some of you may have heard of these two fellows, decided to ask me to start a program. So I first refused because I think that's the polite thing to do, while thinking, what fun. So then I started. Now, I want to tell you what I'm going to tell you in just a brief capsule. Very soon, in about a few months after I started, I realized a number of life lessons. One is that if you're not a server vendor, it's very difficult to, and you're not a specialized storage vendor in HPC, it's very difficult to get into this market. Two, that unless you have a field organization that is dedicated to HPC, it's again very difficult to get into this market. Three, even if you manage to get into this market and sell quite a bit, which we actually did, you never know for sure how successful you've been because there is no way to track the results. So these are the lessons. Like the main lesson is the one that actually caused me to go to the EMC executives and board several times and say, we need to acquire a server vendor. And I'm glad that finally they listened. So, okay. So I already mentioned that, this is a well-known fact. It's very challenging for any vendor to invest in HPC. The supercomputing, the lunatic fringe, where my best friends live, requires a significant technology investment, and the return is somewhat strange. It's very lumpy. Sell $200 million system one day, and then you have a dry year for the rest of the year, or more or less like this. And at that level, the big supercomputing market, the big supercomputing level of the market where, my friends from Craze and IBM are, it's not entirely clear that the market growth is vertiginous, right? Now, on the other hand, in commercial HPC, where I think we all I learned from experience that it's a much more lucrative market, much more predictable, and a very desirable market to be in, also requires a significant technology investment besides all the other factors that I mentioned in the beginning. So within context, Tucci and Gelsinger said, hey, let's go into HPC. So I said, why? I mean, aren't we happy enough in the enterprise market? So Joe smiled, and Pat said, because that's where innovation happens. And that innovation will trickle down into the enterprise market, which we need to be. If we don't play, we don't play. We're going to start losing ground in the enterprise market. I thought, okay, that's why these guys are CEOs. I mean, they're way smarter than me. I bought that argument and I started. Now, since we didn't know my group, personally and my group, didn't know a hell of a lot about HPC, I started establishing some mentors. One of them was Earl, actually, early on. Another one was Rash Hazra from Intel fame. And another one was Gary Grider from Los Alamos National Lab. So we started working. So I said, let's try to figure out learn by doing. So we went into the DOE labs. We established a relationship with Los Alamos. We got awards and for what we've done. The first thing that we did, I'm going to go through this in a second. We got funded during Fast Forward to develop some new technology, which in effect is in the same circle of the burst buffer-based I/O, which now has become a requirement definitely in all the exascale system, but also in peta scale machines. We decided to work with partners, a long list here. We started contributing intensely to open source, which, one of the advantages of not being a business, being a group in the office of the CTO, as we were, is that no one is looking askance at you and you say, oh, I'm writing code for open source. So we actually wrote quite a bit of that. I work with universities and research, right? UTexas is a great example, Purdue, UCSD, a lot of them. Okay, so what has been our focus in this side of our activities, which was to actively do research and advanced development? Essentially sold the first 5 burst buffers in the galaxy. It wasn't our idea. It was definitely a Los Alamos idea, has been rolling around for a couple of years. We started working with Gary. We knew a lot about Flash, right? And we had Flash products for many years before that. So we implemented a burst buffer, and those were sold to Los Alamos, and installed on Buffy, appropriately named, which has acted as a testbed for Trinity later on. We expanded the burst buffer notion to ABBA. It's spelled this way because our legal folks said you can't use uppercase because that name is taken. So, but, it had nothing to do with that other than, people, I'm going to say of my age, have a special soft spot for that formation, for the band. But what he meant was exactly the little string that you can see there, microscopically, of flash boxes interposed between the compute fabric and the disk storage. So why ABBA? I forgot to tell you that. I told you the story about the band. Because that stands for Active Burst Buffer Appliance. And it is active because you said, why don't you use the CPU and the GPGPU in that burst buffer to do some function shipping and do some analytics, freeing the compute cluster from that work, do some analytics in parallel with the compute on the last checkpoint that has been saved, which is a consistent data set, right, representing a stage in the simulation, which is a great tool for simulation steering, right? People are looking at every couple hours at how the simulation looks. They visualize this and say, oops, I screwed up. I mean, the initial parameters were wrong. So they go back without having to wait for weeks. Then this is the fast-forward effort, which we redesigned the burst buffer called IOD. Anybody's guess what that means? It was a joint effort with Intel, Cray, and the HDF group. It was a very interesting effort, actually, which, in a way, it also intended to get rid of the POSIX interface, which I'm not sure it did. So we co-designed with Cray the first burst buffer for Trinity, and then we decided not to participate in the bid because we couldn't see how we monetize that. And then eventually we ended up with the 2 tiers effort, which fundamentally restructures the I/O stack into 2 tiers. What we call the fast tier, which is typically a flash tier. Doesn't have to be, but it's typically a flash. It's a very fast tier. It's a cluster of devices connected to the compute cluster, where the execution really happens. That's where the data is, right? So this is a complete departure from the checkpoint idea, although you can do checkpoints too. And a capacity tier, which in our view of the things is an infinitely pangalactically scaling object store, right? Cheap spinning drive. So we targeted this at a much broader market. We thought that this would work in hyperscale, this would work in the enterprise. I had to throw the stack disaggregation. It's such a nice buzzword. I don't know what it means, but it's good. So, oops, I'm going back. Okay. We also worked, and we have the VMware fellow here who spent the last few years developing, morphing the hypervisor into a very, very usable environment for HPC. We call that concept virtual HPC. So I just carved this out of the fast-forward document just only to impress the people who like to see lots of boxes and circles. That thing in the middle, the yellow, is actually the EMC part. Okay, so what's the bottom line, right? One great thing, very notable success that we had was we basically, doing this, we ended up building a nice, wide Rolodex, contact lots and lots of customers, and expand the penetration of Isilon in particular in life sciences. DSSD, in fact, it is being used as TAC and some other places as Scratch, right? Very fast Scratch. And we started positioning ECS as an object store for campaign archival, which is the deep cold thing. Notable in a different sense, right? And I'm not sure this is bad, but I really wish we could have created a bunch of products out of ABBA and burst buffer and so on, and we didn't. And we didn't simply because this fauna is really living much more comfortably in the server environment. than in the storage. So it wasn't really a good way to justify a business based on this advanced technology. Now, other people have, since we work with the DOE, most of our work has been in the open domain, and people can take it and run with it. So this is a long list. I don't want to do more than to flash this before your eyes, but focus on the 4 key products that are, in fact, they were very incipient when we started, and now are getting into their own and are a perfect fit for a variety of HPC market verticals. VMware I mentioned, VirtuStream, and that's a bunch of technology and connections. This is our, how should I put it, dowry that we bring into this relationship. Right? I'm mixing metaphors here. Okay? It was a birth, but now it's a wedding. But whatever it is, it's good. And it's good because, I'm going to skip this fairly obvious things which are check, 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 right? And get to the bottom line today, particularly today. We see great synergy in the work with Dell, within Dell EMC, within Dell Technology. We completely embrace the vision that was shown before that Michael and his folks posited. And, with some nostalgia regarding the VNX that used to be sold by Dell many, many years ago in that corner. And with a new logo. So that's it. I think I was pretty much on time. Maybe not.